Sir, good evening, sir.
Good evening, sir. Good evening.
Shall we start now, sir?
Okay.
Okay, sir. Thank you. Good evening, everyone. We welcome you all for 5 days online SPSS workshop in research. This is Dr. S. Shekhar, founder and managing trustee of Star International Foundation for Research and Education. Let me introduce a few words about our today's resource person, Professor Dr. D. Kumaresan, sir. MCom, MSc Psychology, MBA, MA English, MPhil, PhD. He is an eminent academician and popularly known for his simplicity. He is qualified in state-level eligibility test in commerce conducted by Bharatidasan University in the year of 2000. He has completed Chartered Accountant intermediate examination, one group of final examination. His area of specialization are financial management and marketing management. His academic services spans over a period of 25 years in teaching, which include 20 years of research activities. Having started his career as lecturer by his proactive and dedicated services in reputed colleges, he was elevated and served as the principal for 12 years. He has served as a Senate member of Periyar University, Salem. He has acted as the external examiner for the conduct of PhD public vivas examination for 17 candidates. He has acted as a resource person for the refresher course, research methodology course, faculty development program, NET or SET coaching for paper 1 and paper 2, commerce conducted by various universities. He has acted as a resource person for more than 300 international or national conferences, seminar, workshop, and webinars. He is a motivational speaker and has served as the resource person for more than 160 motivational program and conducted a training program on positive thinking, time management, memory techniques, and stress management. His research activities are: he has guided 5 PhD scholars and 22 MPhil scholars. He has published one book and more than 43 papers in referred journal or edited books. He is a proud member for the following academic forum of and social organization. He is the member of Board of Studies in various reputed higher educational institutions. He is a member of Research Advisory Committee, Amity University, Jharkhand. He is peer review committee of reputed journals. He is a life member of Indian Academic Researchers Association, Trichy. He is a member of Indian Association of Social Science Research. He invaluable contribution to the teaching fraternity, students community, and the society has brought more than 20 awards. Other credential: he has got the opportunity to meet and interact with the former President of India, Dr. APJ Abdul Kalam, during the travel from New Delhi to Coimbatore. He has been delivering lecture series, 9 days each discourse on the great Indian epic Ramayana. At present, he has been working as a professor and a director, School of Commerce, KSR College of Arts and Science for Women, Tiruchangod, Namakkal District, Tamil Nadu. I welcome you, sir.
Thank you.
Thank you, friends, those who are joining the 5 days online workshop. Now the session is handed over to our today's resource person, Dr. D. Kumaresan, sir.
Very good evening. Dr. Shekhar, and all the beloved participants, warm and pleasant evening to one and all. At the very outset, I would like to thank Dr. Shekhar and his team for having organized such a wonderful program, that too free of charge. Whether charge is collected, fee is collected, or the program is given free of cost, the purpose is to disseminate the knowledge or expertise among the teaching fraternity, particularly those who are interested in research activities. So this program has been organized or designed with 5 modules. For the next 5 days, we are going to discuss about various statistical tools to be applied in the data analysis. Today, we are going to discuss about the correlation. Earlier in the previous program, we have completed parametric tests and non-parametric tests. In the parametric tests, we discussed the one sample t-test, independent samples t-test, parent samples t-test, one-way ANOVA, and two-way ANOVA. In the case of non-parametric tests, we discussed Mann-Whitney test, Kruskal-Wallis test, Wilcoxon test, Fredman test, and chi-square test. So I hope you are all aware of these parametric and non-parametric tests. Today is exclusively meant for correlation. Correlation can also be categorized as parametric as well as non-parametric. If the data are given in scale data, the data are scale data, we have to apply parametric correlation test. If the data are ordinal data, we have to apply non-parametric correlation. So 2 methods of correlation. They are popularly known as Karl-Pearson's correlation method and Spearman's correlation method. Under the Karl-Pearson's method, the data are given or collected as scale data. Scale data means the data which has real values. The data which have real values like marks obtained or scores obtained, or in the case of a financial analysis, we know net profit, gross profit, operating profit, sales or cost, or even in ratios, profitability ratio, like net profit margin, operating profit margin, then ROCE, ROA, similarly RONW, return on net worth. They are given with real values. If real values are given, or sometimes we are collecting the salary or income earned or expenditure spent. Sometimes we are comparing the sales revenue and the advertisement expenses, or some operating expenses also can be compared. They are real values. In the case of real values, we have to apply Karl-Pearson's coefficient of correlation. The data are given as ordinal data. In that case, we have to apply Spearman's rank correlation coefficient. So these are the basic things we have to understand. Okay. What do you mean by correlation? Correlation is a measure or tool used to find out the relationship between two or more variables. It's the relationship between two or more variables. So the variables are compared. For example, two firms are taken. Net profit of two firms are compared. In that case, we have to apply correlation. Here, we should understand the difference between independent sample t-test and correlation. Suppose you may have doubt, sir, both are looking similar, sir. In the case of independent sample t-test also, we are collecting scale data. It is a parametric test. We are comparing two groups. Yes. Here also, all are same what we have discussed. The data are scale data. We are comparing two variables or two groups. Then in what way it is different from t-test? Where should we apply independent samples t-test and where should we apply correlation? In the case of independent samples t-test, there is no necessity that the number of items of the two groups should be equal. It need not be equal. Group 1 may consist of, for example, 15. The sample size of group 1 may be 15. Group 2 may be 20 or 25. In that case, we can apply independent samples t-test. But in the case of correlation, number of items in each group should be equal. Group A, 20. Group B also must be 20. For example, in the very basic statistics, we would have studied heights of fathers, heights of sons. So 1 to 1, one father, one son, another father, another son, third father, third son. Likewise, in a street or in a locality or in a school or in a college, 100 students are there, 100 parents are there. So father's height and son's height are compared. Father's weight and son's weight are compared. Father's IQ and son's IQ or daughter's IQ are compared. So here, number of items in each category or in each group is equal. Unlike in the case of independent samples t-test, where we compared boys and girls in a class. There are 15 boys and 20 girls. We can apply independent samples t-test. But in the case of correlation, we should understand the data must be scale data. Yes, of course, it is common for both independent samples t-test and correlation. Then the other thing is number should be equal. That is the difference between independent samples t-test and correlation. So here I told you about the parametric test. Since the data are scale data, we are going for parametric test. The correlation may be divided into two again. One is simple correlation and another is multiple correlation. Simple correlation and multiple correlation. What is simple correlation? When we are comparing two variables only, we are comparing two variables, variable 1 and variable 2. They are only compared. Or two groups only. Suppose height is a variable, two groups, height of father, height of son. So two groups are compared. Only two groups are compared. In that case, we call it as simple correlation. Then what is the other one? The other one is multiple correlation. Other one is multiple correlation. In that case, more than two variables are compared. Or more than two groups are compared. For example, in the case of, again, finance-related analysis, we may compare two or more variables of a single firm. Company ABC Limited is taken. We are comparing sales and net profit. We are comparing sales and net profit. Sales is one of the variables. Net profit is another variable. So here they are called variables. We are comparing the variables. In that case, we can apply correlation. If only two variables are compared, we are applying simple correlation. If more than two variables are compared, suppose sales, operating expenses, and profit, they are compared. Net profit or operating profit. So more than two variables of a single firm, more than two variables, three variables or four variables like that, we are comparing. In that case, we have to apply multiple correlation. Sometimes more than two firms are taken. Single variable, two firms are taken, more than two firms are taken. Company ABC Limited, PQR Limited, XYZ Limited. Net profit for 5 years or 10 years we are taking. Or sometimes we are comparing the net profit alone for three firms or four firms or five firms in the industry. Automobile industry we are taking. We are comparing Maruti Suzuki Limited, Tata Motors Limited, Bajaj Auto Limited, Hero Motor Car. Like that, we have taken some 4 or 5 companies. Net profit of these companies are compared. In that case also, the data are scale data. More than two groups are compared. Earlier, more than two variables are compared. Of a single company, ABC Limited, profit, sales, and cost are compared. Or capital, or net worth, they are compared. Or total assets are compared. In that case also, we can apply multiple correlation. It is also called as multiple correlation. Yet another categorization is there. That is positive correlation and negative correlation. What is positive correlation? I told you, no, two variables are compared. Or in the case of multiple correlation, more than two variables are compared. Okay. If the variables move in the same direction, the variables are moving in the same direction, it is called positive correlation. If the variables move in the opposite direction, it is said to be negative correlation. For example, sales are increased. Net profit is also increased. When sales are increased, net profit is also increased. So both are increasing. Both are moving in the same direction. It is called positive correlation. Sometimes both may be decreasing. Sales are decreasing, profit is also decreasing. It is also positive correlation. Please note it. If both the variables are increasing or both the variables are decreasing, we say that the variables are moving in the same direction. Either both are increasing or both are decreasing. We call it as positive correlation only. Then what is negative correlation? In the case of negative correlation, variables move in the opposite direction. One variable increases, another variable decreases. Or one variable decreases, another variable increases. So if the variables move in the opposite direction, for example, if cost increases, profit decreases. If cost decreases, profit increases. Is it not? In that case, it is called negative correlation. So if the variables are moving in the same direction, it is said to be positive correlation. If the variables are moving in the opposite direction, one increases, another decreases, or one decreases, another increases, it is said to be negative correlation. That's it. It is measured in terms of degree. That measurement is known as coefficient of correlation. That measurement is known as coefficient of correlation. So it is a measure. It is the degree to which the variables are correlated. So correlation is the relationship, correlation, that is called correlation. So correlation is the relationship between two or more variables. When two variables are compared, it is simple correlation. When more than two variables are compared, it is said to be negative, multiple correlation. If both the variables move in the same direction, it is positive correlation. If the variables move in the opposite direction, it is said to be negative correlation. So the measurement is known as correlation coefficient. Correlation coefficient. It denotes the degree to which the variables are related. Degree means percentage. Degree means percentage to which the variables are related. So if it is percentage, understand it should never exceed 100. It should never exceed 100. The maximum 100%. Here we are comparing both the positive and the negative correlation. So the coefficient of correlation must be between -1 and +1. Between -1 and +1. If it is negative, it will be between 0 and -1. If the correlation is negative, the correlation coefficient will be 0 between 0 and -1. If the correlation is positive, then the coefficient of correlation between should be between 0 and +1. So generally, we say that the coefficient of correlation should be between -1 and +1. So in between these two, extent, that is -1 and plus 1. Can you repeat? Yes, I am repeating. Correlation is the relationship between two variables. That relationship is measured as a percentage. So the maximum percentage would be 100. The maximum percentage would be 100, not more than 100%. So if it is measured in decimals, it should be between -1 and +1. In the case of positive correlation, the coefficient of correlation will be between 0 and +1. In the case of negative correlation, it will be between 0 and -1. That's all. So that's all about the correlation. So Karl Pearson's correlation method is the most popular method. It is a parametric test because we are using the scale data. It is immaterial how many variables we are going to compare. We can compare 2 variables, 3 variables, 4 variables, or 5 variables. Any number of variables we can compare. Suppose if the data are collected as ordinal data, like we are collecting ranks. Ranks are collected. Instead of scores or marks, we are collecting the ranks. Ranks are called ordinal data. Real values are called scale data. In the case of scale data, we have to apply Karl Pearson's coefficient of correlation. In the case of ranks, it is said to be ordinal data. In the case of ordinal data, we have to apply Spearman's rank correlation coefficient. That's all. So basically, correlation is the measurement used to understand the relationship between two or more variables. In the case of correlation, the variables are called interdependent. They are called interdependent. There is no dependent or independent variable. In the case of t-test, we had dependent variable and independent variable. But here, the variables are not called dependent or independent. They are called interdependent. So I am related to my son. My son is related to me. Likewise, that correlation. And in the case of multiple correlation also, at a time, only 2 variables are compared. Even though we are comparing more than 2 variables. For example, variable 1, variable 2, variable 3, variable 4. We are comparing 4 variables. That is called a multiple correlation. Here, the comparison is made between 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, then 3 and 4. Like that only, that comparison is made. So even in the case of multiple correlation, simple correlation is applied for each combination or each pair of variables. That's all. Like permutation and combination, So for each combination of or each pair of variables, a simple correlation is applied and it is consolidated. The result is said to be multiple correlation. That's all. So this is about the correlation. Now, the correlation may be analyzed with the help of SPSS. Those who are attending the workshop with the laptop and the SPSS installed in your laptop may open the data already I have given. that must have been shared with you in the group. So sample data set has been given along with the problems. Now let me show the problems. First, a Word document is there. No, you open that Word document. Hello, am I audible now?
Yes, sir. Yes, sir.
Okay, sir. Thank you. Sorry, friends, for the technical issue. I have been disconnected and I couldn't get connected with you for the first few minutes. I'm sorry. I'm extremely sorry. Okay, now let us proceed. I'll share the problem. I have given you a Word document like this. Problem number 1, correlation. This is Carl Pearson's method. The following are the marks scored by the MBA students of a B school in the university examinations. So we have taken 20 students and marks of 5 subjects: marks in cost accounting, marks in income tax, marks in supply chain management, marks in research methodology, marks in investment management. So 5 subjects are given. What happened? Second, screen sharing option is disconnected for me.
Screen share.
And now it is enabled. Yes. Okay. Is it visible now? Second, dear friends, are you able to look at the screen now?
Sir, visible, sir.
Okay. Thank you. Now look at this. There are 5 subjects in MBA class, and the students have got marks in the 5 subjects. You are required to examine whether there is any significant relationship, whether there is any significant correlation between the marks obtained by the students in various subjects. So cost accounting is one of the subjects, income tax, supply chain management, research methodology, and investment management. Okay. See here, in the case of all the variables, marks in cost accounting is one variable. So 2, 3, 4, 5. Now let us see simple correlation. First, let us take cost accounting and income tax only. Cost accounting and income tax only. For the purpose of saving the time, I have given you the data set. Look at this. This is variable view and this is the data view in the SPSS software. Now let us go to the analysis relating to 2 variables only. We are comparing cost accounting and income tax only. It is said to be simple correlation. It is said to be simple correlation. So go to analyze. On the top of the menu bar, look at this. The 6th menu of the top of the menu bar. First one, file. Second one, edit. Third one, view. Fourth one, data. Fifth one, transform. And 6th one. 6th one is meant for analyze. This is the only gateway for all the tools which are going to apply. So go to analyze. A drop-down menu appears like this. Reports, descriptive statistics, tables, compare means, GLM, general linear model, then generalized linear model, mixed models, correlate. We are going for correlation. So correlate, bivariate. What do you mean by bivariate? Bivariate, bi means 2. Only 2 variables are compared. I told you, in the case of multiple correlation also, the correlation is made between 2 groups only. I mean, two variables only. So combination between A and B, between A and C, between A and D, then between B and C, between B and D, then C and D, like that only we are. So it is called as bivariate analysis. So if you click that, you can look at this window. In this window, there are two boxes. The first box is meant for the variables in the data set. In our data set, there are number of variables. In the second one, that is the box appearing on the right hand side of the window, is meant for variables to be tested. Look at here, variables to be tested. So here I told you, no, we are comparing marks in cost accounting and marks in income tax. So either you can select one by one and drag it one by one, or otherwise you can select both. Either you can drag it to the right hand side, or you can use this arrow key. Using this arrow key also, you can bring the variables to the test variables box. Right. Look at here. Carl Pearson's coefficient of correlation. It is selected in default. It is selected in default. Then two-tailed or one-tailed. Either negative only or positive only means one-tailed. Both are to be considered means two-tailed. Okay, we are comparing two-tailed. Then the last box checked is flag significant correlations. It is already checked in default. Pearson is already checked in default. So we need not do anything here. Only two variables are compared. Marks in cost accounting and marks in income tax. They are compared. Method is Carl Pearson's method. Test of significance is two-tailed. Flag significant correlations. Flag significant correlations means if the correlation is significant, it will be notified. That's all. Notified with stars. Now you go to OK button. Click the OK button. Now look at the output. See here, marks in cost accounting, marks in income tax. They are shown both in the rows and in the columns. If the same subject is compared, correlation measurement will be 1. Marks in cost accounting versus marks in cost accounting, the Pearson's correlation coefficient is 1. Similarly, look at here, marks in income tax versus marks in income tax, the correlation coefficient is 1. Okay. Now, cost accounting versus income tax. Cost accounting versus income tax. That is correlation between marks in cost accounting and marks in income tax. Look at this, 0.801. 0.801. That is what I have shown in the Word document also. Look at here. As usual, we have to make the hypothesis. Then I have shown here. It is multiple correlation. So in the case of simple correlation, look at here. The correlation coefficient, it is usually denoted by rho, Greek letter rho. It is not R, it is rho. So rho is 0.801. I told you, no, the coefficient of correlation must be between 0 and +1 if it is positive correlation. If the variables are positively correlated, the coefficient of correlation will be between 0 and +1. If it is negative, that is why we are comparing two-tailed. Both of the tails are compared. We have to understand whether it is positive or negative. So only we are comparing both tails. So if the coefficient of correlation is negative, then the coefficient of correlation will be between 0 and -1. 0 and -1. So here, correlation coefficient is 0.801. It is positive. So no negative sign is given here. So it is positive. It is treated as positive correlation. To what extent? 80%. 0.801 means 80.1%. So if one variable, that is, if marks in cost accounting increases by 1 mark, marks in cost accounting will be increased by 0.8 mark. That is what we can understand from this. So both are moving in the same direction. If one increases, another also increases. If one decreases, another also decreases. Okay. Then look at the significant value. Look at here. It is 0.000. If it is 0.000, it is less than 0.01. If it is less than 0.01, we say that it is significant at 1%. It is significant at 1%. While computing, we have found that the flag significant correlations box was checked. I told you it will be notified with stars. Look at this correlation coefficient. It is marked with 2 stars. 2 stars means significant at 1%. 1 star means significant at 5%. If no star is given, it means there is no significant relationship. So, correlation between marks in cost accounting and marks in income tax, it is measured with the Karl Pearson's coefficient of correlation. So the Karl Pearson's coefficient is 0.80 positive. So there is a positive correlation between marks in cost accounting and marks in income tax. Other way, we can compare, see, A to B we compared. Similarly, B to A we are compared. Marks in income tax is compared with the marks in cost accounting. In that case also, look at here, the coefficient is 0.80. So what do we understand? Whether A to B is compared or B to A is compared, it is giving the same result. It is giving the same result. 2 into 3, 6. 3 into 2, 6. In the same way, here, if A to B is compared, or B to A is compared, it is giving the same result. So 0.801, number one, positive correlation. Okay. Then significant value 0.000. So it is significant at 1%. That is notified with 2 stars. Then as I told you, look at this, number is equal in both the cases. Here A to B, B to A, the results are same. If two variables are compared, I said it is simple correlation. The output in the SPSS will be looking like this one day. So here, this is called a correlation matrix. That is, this part. This part is known as correlation matrix. This part is known as correlation matrix. Okay. Now, this 1, 1 is called as diagonal. It is called as diagonal matrix. The diagonal is always unit matrix. That is, the value is always 1. Value is always 1. So the values above the diagonal and below the diagonal are same. The values above the diagonal and below the diagonal are same. So what can we do? We can delete these things. In the output, we can delete the values above the diagonal. We can take the values below the diagonal. Right. Now, what is the coefficient? It is 0.8. 801. I said it is 80.1%. Now, what is the degree of correlation? What is the degree of correlation? 0.8 is the coefficient of correlation. What is the degree of correlation? For that, we have a standard parameter. If the coefficient of correlation, if the coefficient of correlation is between 0 and 0.25, that is above 0, but less than or equal to 0.25. That is said to be very low degree of correlation. If the coefficient of correlation is less than or equal to 0.25, we say that it is very low degree of correlation. Okay. Then, if the coefficient of correlation is above 0.25, but less than or equal to 0.5, less than or equal to 0.5, we say that it is low degree of correlation. Low degree of correlation. If it is less than or equal to 0.25, very low degree of correlation. Above 0.25, but less than 0.5, less than or equal to 0.5, we call it as low degree of correlation. If the correlation coefficient is above 0.5, but less than or equal to 0.75, we call it as moderate degree of correlation. Above 0.5, but less than or equal to 0.75, it is called as moderate degree of correlation. Then the next slide. The coefficient of correlation is above 0.5
Dear participants, please wait up to 5 minutes.
Segar,
Yes, sir.
am I audible?
Yes, sir. Yes, sir. Please share your screen, sir.
Is it visible now?
Visible now, sir.
Okay, okay. Sorry, dear friends, some technical issues. Yeah, this is what we have discussed. Degree of correlation is, I told you no, uh, less than 0.25 means very low degree. Between 0.25 and it is said to be low degree of correlation. Between zero point 0.5 and 0.75, it is moderate degree of correlation. Between 0.75 and zero point 0.9, it is called a high degree of correlation. Then between zero point 0.9 and 0.99, it is said to be very high degree of correlation. If the coefficient of correlation is 1, it is said to be perfect correlation. It is said to be perfect correlation. If it is 0, we call it as no correlation. If it is 0, there is no correlation between the variable. That's all. So positive correlation, number 1. Then coefficient of correlation is 0.801, number 2. Then it is significant. And that too, see, while computing this, we have checked the flag significant correlations. If suppose I unchecked it, look at this, there is no stars. There is no stars superscribed with this coefficient of correlation. See the difference. So for that purpose only, we are using that option, flag significant correlations. So analyze correlations bivariate. Then here flag significant correlations. Okay. Now once again we got the significance or not. Okay. So this is simple correlation. Now let us go to the multiple correlation. For that also the same procedure. Analyze correlation, bivariate correlations. Then we can reset. You bring all the 5 subject marks here. Then the same Pearson two-tailed flag significant correlations. Now click OK. Now look at this. See, I told you no, the diagonal, prime diagonal is always number 1. We call it as unit matrix. The unit diagonal. This diagonal is always 1, 1, 1, 1. I told you no, the values above the diagonal and below the diagonal will be same. Look at here, it is 0.801, 0.801, 0.440, 0.440, 0.551, 0.551, 0.515, 0.515. Here 0.438, 0.438, 0.490, 0.490, 0.593, 0.593. Then here 0.712, 0.712, 0.756, 0.756, 0.641. Here also it is 0.641. That's all. So I told you no, you can delete these values. Above the diagonal, you can delete the values. Look at here in the Word document, I have shown you. See, I have deleted the values above the diagonal. This is diagonal and the values are 1. I have deleted for your easy understanding. Look at this. I have just copied and pasted the result here. The same result, cost accounting versus income tax 0.801. Previously, we got it. No, see here 0.801. The same result, the same analysis, same result. Then cost accounting versus SCM, supply chain management, it is 0.440. Look at the significant value 0.052. It is greater than 0.05, so it is not significant. So no star is superscribed. Here two stars are there. Two stars means significant at 1%. One star means significant at 1%. No, I mean 5%. No stars means not significant. So cost accounting and supply chain management are not significant. The degree of correlation is, I mean, coefficient of correlation is 44, low degree of correlation. Less than or equal to 0.25 means very low degree of correlation. Above 0.25 but less than or equal to 0.5 means low degree of correlation. So here cost accounting and supply chain management are correlated positively at low level. At low level, it is not significant. It is not significant. Then you come to the next one, cost accounting and research methodology. The coefficient of correlation is 0.551. That means 55.1%. Significant value is 0.01%. So greater than 0.01 but less than 0.05. So significant at 1%. So here only one star is superscribed. So it is correlated at 0.551. Correlation coefficient is 0.551. So above zero point 0.5 but less than or equal to 0.75 means there is a moderate degree of correlation between cost accounting and research methodology. Then come to investment management. What is the correlation coefficient? 0.515. P value 0.020, less than 0.5, 0.05. So significant at 5% level. So only one star. They are positively correlated at 51.5%. 0.5 means greater than zero point 0.5 but less than 0.75. So here also moderate degree of correlation. So cost accounting and income tax, high degree of correlation. Cost accounting and supply chain management, look at here, not correlated, not significantly correlated, less than 0.5. So low degree of correlation. Here, cost accounting and research methodology, moderate degree of correlation. Cost accounting and investment management also moderate degree of correlation. Then come to income tax and supply chain. It is 0.438. It is also low degree of correlation. Look at this. Significant value is 0.053 greater than 0.05. So there is no significant correlation but positively correlated at low level. Income tax and research methodology 0.490. 0.490 but significant value is 0.028. Even though low degree of correlation, it is significant. Previously 0.438 That is also low degree of correlation, but it is not significant because the p-value is greater than 0.05. Here it is 0.490 is also low degree of correlation, positive correlation, but p-value is less than 0.05. So the correlation is significant. Similarly, come to the next one, income tax and investment management. Correlation coefficient is 0.593. 593 means moderate degree of correlation. Significant value is 0.006 is less than 0.01. So significant at 1% level. Significant 1% is denoted by 2 stars. So income tax and supply chain management, not significant. Positively correlated at low level. Income tax and research methodology, positively correlated at low level but significant. Low level but significant. Income tax and investment management, positively correlated at moderate level, significant. Then come to the next one, supply chain management and research methodology, 0.712, less than 0.75. That is also moderate, but p-value is 0.000. So highly and positively significant. The correlation is highly and positively significant. Similarly, supply chain management and investment management, it is 0.756. 756. So above 0.75. Above 75 means high degree of, here it is moderate, here it is high degree of correlation. Significant value is 0.000. So significant. Correlation is positive and high degree of correlation. It is significant. Supply chain management and research methodology are positively and moderately correlated at 1% level of significance. Supply chain management and investment management are correlated at high level. The correlation is significant and positive. Then come to the last, research methodology and investment management. Coefficient is 0.641. So it is less than 0.75, moderate. Less than 0.75 means moderate. But p-value is 0.00. So it is significant 1%. It is denoted by 2 stars. So research methodology and investment management are positively and significantly correlated at moderate level. So this is what the interpretation we have to write. So what is the highest degree of correlation between which subjects? Highest degree of correlation, look at this. This is 0.801, 0.440, 0.551, 0.515, 0.438, 0.490, 0.593, 0.712, 0.756, 0.641. So obviously 0.75 is the highest one. So the highest correlation is found between cost accounting and income tax. The lowest correlation coefficient is 0.438. So income tax and supply chain management are correlated, are having the lowest correlation among the 5 subjects. First one, we understand the correlation, then degree of correlation, then positive or negative, then level of significance. These are the things we have to understand. 1 star means significant at 5%. 2 star means significant at 1%. That's all. So this is what about the multiple correlation. Then, so we have seen what is simple correlation and what is multiple correlation. These are all coming under Carl Pearson's coefficient of correlation because the data are given in scale data. Now look at here. We can have the mean marks. How to calculate mean, standard deviation, and number. Again, you go to analyze, descriptive statistics, go to descriptives. What are the items we want to know? These are the things. Then go to options. Look at here, mean, standard deviation, minimum, maximum. Continue. Now you can see number 20 in all the cases. 20. The lowest mark in cost accounting is 52. Highest mark in cost accounting is 98. The mean marks, average marks obtained by the students in cost accounting is 74. Then income tax. Lowest mark 58, highest mark 100. The mean mark 76.9, average mark. Supply chain management. Lowest 58, highest 93, average 72.35. Then research methodology. Lowest mark 58, highest mark 92, average 76.05. Then marks in investment management. Lowest 62, highest 94, average 78.15. Why we are calculating the average marks? Now look at this. Cost accounting average is 74. Income tax average is 76.9. Supply chain 72.35. Research methodology 76.05. Investment management 78.15. So which subject has got the highest average marks? Investment management. Lowest average mark 72.35 in supply chain management. However, look at this. The individual highest mark is 100 in income tax. Individual highest mark is 100 that is scored in income tax. But the average marks, it is 17.9. Why this is happening means look at the range. Minimum 58, maximum 100. Here, minimum 62, maximum 94. That is why the standard deviation is computed. In this case, standard deviation is low. In this case, standard deviation is low, but in the case of income tax, standard deviation is high. So the average is reduced because of this deviation. It is lowest is 58 and highest is 100. Here lowest is 62 above this, and here look at variation 62 and 94. The difference is just 32. It is measured in terms of standard deviation as 9.4883. Whereas in this case, lowest 58, highest 100. Lowest 58, highest 100. But average is less than this because of this standard deviation. Look at this, it is 17. So highest, I mean the variation is high, in the case of income tax. So that average is not the highest one. But look at the lowest one, 5293. Okay, 52 and 93. But the average mark is 72.35. Why? Here 68 and 94. Lowest is 68, highest is 94. This standard deviation is 9.483. Here 58 and 93. Not a greater variation between 68 and 62, 94 and 93, no greater variation. Similarly, it is 9.980, it is 9.483. There also there is no greater variation. Then why this average is less? That means number of marks having lower marks will be high. Look at this, 83, 63, 68, 58, 82, 68, 72. Look at this, less than 60. How, for example, less than 60, how many? Or less than 70, how many items? Number one, two, three, four, 5, 6, 7, 8, 9 marks are less than 70. Just to check, I told you here value. Here, look at this. What is the other one? Here, investment management. Look at this. Less than 70, 1, 2, 3, 4. Only 4 marks are less than 70. But here, 9 marks are less than 70. So only the average is lowest. So this is what about the correlation. It can be compared in another way also. Go to analyze, compare means, then means. Go to analyze, compare means, and go to means. Here you can take all the values in the dependent list. What are the things you require? Mean, number of cases, deviation, minimum, maximum. Then continue. Okay. Now look at this. Minimum, number, standard deviation, mean, number, standard deviation, minimum, maximum. The same results. Look at this. Here it is given in rows, here it is given in columns. That's all. Here, row wise, number, minimum, maximum, mean, standard deviation. Here, number, mean, standard deviation, minimum, maximum. 52, 98. 98. Average 74, standard deviation 13.780. Same result. So in two ways we can calculate. In two ways we can calculate. That's all. Okay. So this is about the multiple correlation. So Carl Pearson coefficient of correlation is over. Now let us go to the next problem. Look at here. The following are the ranks secured by MBA students of a B school in CAA, Continuous Internal Assessment, Test 1 and Test 2. So here, instead of giving the marks, the ranks are given. If ranks are given, I told you no, it is ordinal data. You are required to examine whether there is any significant relationship between ranks secured by the students in CAA 1 and 2. Okay. Now, data. Analyze. Again, the same way. Correlate, bivariate. Now let us reset. select the rank 1 and rank 2. Rank 1 and rank 2. We have chosen. Now you have to uncheck the Pearson and check the spearman. Check the spearman. Then click OK. Look at here. Rank 1 and rank 2. The diagonal max is 1. 1, 1, 1. Look at this. It is 0.949. Here also it is 0.949. Second vacant value 0.000, 0.000. 0.9 means 949 means 95%, almost 95%. So 9% means high degree of correlation. That is a very high degree of correlation between 90 and 99. It is very high degree of correlation. Positive correlation, very high degree of correlation. Numbers are equal. Since it is given in ordinal, I told you no, non-parametric correlation. Non-parametric. Carl Pearson is parametric correlation. It's not given parametric correlation. It is non-parametric correlation. That's so coefficient of correlation is 0.949. 949 means very high degree of correlation. Since the p-value is 0.000, it is significant at 1%. It is denoted by 2 stars. Now, if we uncheck the flagsheet, what happens? That stars are not appearing. Stars are not appearing. Similarly, if we are checking that, it is again applied. Point 949. That's all. Here, since it is ordinal data, that is, ranks are given, we should not calculate the mean. We should not calculate the standard deviation or anything. Because they are ordinal. They are ordinal. Mean and standard deviation or minimum maximum may be computed only for the scale data and not for the ordinal data. Since it is ordinal data, we are not computing the mean or standard deviation. Now look at this ranks 20, 11, 17, 7, 16, 10, 12, 9, 15. These are ranks in test 1. These are ranks in test 2. 18, 2, 16, 7. This is called tied ranks. This is called tied ranks. If the ranks are same in both the tests, it is said to be tied ranks. See, this is the rank of test 1. This is the test 2. If the test 1 rank is low and test 2 rank is high, it is said to be positive. That is, it is moved up. Previous performance was less, now it is improved. But here it is given as rank, not as mark. So if rank is decreased, then performance is increased. Previously, the first boy has got the 20th rank. Now, the same boy has got the 18th rank. So, the performance of the first boy is better than the CAA one. But for the second boy, previously it was 11, now it is 12. So the performance is poor. Third boy, better. Fourth boy, tied rank. He remains the same in the last test and this test also. His performance is same. Then 16 and 15, better. 10 and 9, better. 12 and 11, better. 9 and 8, better. 15 and 14, better. 3 and 6, performance has become weaker or poorer. 4 and 2, better. 8 and 10, poor. 1 and 1, tied. Same, he has maintained a same level of performance. 5 and 5, again tied. 18 and 17, better. 2 and 4, poor. 6 and 3, better. 4 and 19, poor, very poor. 1920, poor. 1313, same. No improvement. No improvement. So 2018, improvement. 2018 improvement. 16, 8, 17, 16 improvement. 7, 7, 16, 15 improvement. 16, 15 improvement. 10, 19 improvement. 10, 19 improvement. 12, 7, 12 and 7, 11 improvement. 9 and 8 improvement. 15 and 14 improvement. 15 and 14 improvement. 4 and 2 improvement. 8 and 10, 1, 5 is to 5, 18 and 17 improvement. 6 and 3 improvement. 14, 19, 19, 20, 13, 30. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9, and 10. Out of 20 students, 10 students have performed better in second test when compared with the first test. Then come to the poor performance. 11 and 12. 11 and 12 poor performance. 8 and 10 poor performance. 2 and 4 poor performance. 14 and 19 poor performance. 19 and 20 poor performance. Look at this. 1, 3, 4, 5. 5 students have performed poorer than the previous test. Now you come to the tied ranks. 7, 7 tied. We have missed no. 1, 1. 1, 1 tied. 5, 5 tied. Then 13, 13 tied. See here 3, 6 poor. So 10 students have improved their performance. 6 students could not improve the performance. Not only that, their performance have become poor. 4 students remained the same performance. So total 20 students, their performance is measured like this. So we can understand how the students have performed. So 10 students out of 20 students, 10 students have given good performance or better performance. That is why we got this result. Look at here, they are correlated at 94, 94.9%, almost 95%. Correlation coefficient is 0.949. Since the p-value is 0.000, we call it as significant at 1%. It is denoted by 2 stars. So this is about Spearman's correlation. So there are two types of correlation: Carl Pearson's coefficient of correlation and Spearman's correlation coefficient. Carl Pearson's coefficient of correlation is to be applied when the data are scale data. Spearman's correlation coefficient is to be applied when the data are ordinal data. When two variables or two groups are compared, it is said to be simple correlation. When more than two groups or more than two variables are compared, I'm sorry, it is said to be multiple correlation. Then, if the correlation coefficient is negative, we say that the variables are negatively correlated. If the correlation coefficient is positive, we say that the variables are positively correlated. So, if the variables move in the same direction, it is said to be positive correlation. If the variables move in the opposite direction, it is said to be negative correlation. The degree of correlation, already I told you, no. 0 means no correlation. Less than 0.25 or less than 25%. It is said to be very low degree of correlation. If it is greater than 0.25 but less than or equal to 0.5, otherwise greater than 25% but less than or equal to 50%, it is said to be low degree of correlation. Then it is greater than 0.5 but less than 0.75, less than or equal to 0.75, we call it as moderate degree of correlation, or otherwise greater than 50% but less than 70, less than or equal to 75%. It is said to be moderately correlated. Above 0.75 but less than 0.9, less than or equal to 0.9, it is said to be high degree of correlation. Otherwise, above 75% but less than or equal to 90%, it is called high degree of correlation. Then above zero point 0.9 but less than or equal to 0.99, it is said to be very high degree of correlation. If the correlation coefficient is 1, we call it as perfectly correlated. Here it is 1. Why it is 1? We are comparing the same variable, cost versus cost, tax versus tax. One means perfectly correlated. That's so positive correlation, negative correlation, simple correlation, multiple correlation, then significance. If the p-value is less than 0.05, it is said to be significant at 1%. If the p-value is less than 0.01, we say that it is significant at 1%. Then finally, the comparison of minimum, maximum, mean, and standard deviation. It should be done, or it may be done only when it is scale data. That is in the case of Carl Pearson's coefficient of correlation, then only we can compute this. For the Spearman's correlation coefficient, mean standard deviation, minimum maximum should not be computed because the data is ordinal data. Since it is ordinal, we are going for non-parametric correlation. So Spearman rank correlation coefficient is non-parametric correlation. So that's all about the correlation we want to learn today. Now it is open to the participants. If you have any doubt, you can unmute your mic and ask the doubt. Dear friends, kindly give the, is it?
Sir,
Yes, 3 and 6 that we have added. One more
sir,
question about the p value. Somebody has asked about p value. P value is the probability value. P value is the probability value. Probability means chance of happening. Probability value means chance of happening. So if the level of significance is 5%, level of significance is 5%. 5% means 0.05. If it is less than 0.05, there is less chance of accepting the null hypothesis. Less chance means we have to reject the null hypothesis. If the null hypothesis is rejected, we say that it is significant. Because null hypothesis, what we take the null hypothesis? You see, there is no significant relationship. Null hypothesis says that there is no significant relationship between marks. So if it is less than 0.05, look at this. If the p-value is less than here, look at this. P-value is 0.053. It is greater. Greater means we are accepting the null hypothesis. Accepting means no significant relationship. That is what it is mentioned here. So no star is appearing here. But here, look at this. It is 0.000. So it is less than 0.05 or even less than 0.01. So we have two stars. It is significant. Null hypothesis is rejected. Alternative hypothesis is accepted. Alternative hypothesis is there is a significant relationship. That's all. Okay. Any other doubt?
sir.
Yes, sir.
Sir, in YouTube, one person asking, sir, one question, sir.
Yes.
How many items are required to apply simple and multiple correlation?
Item means number of frequency.
Yes, sir.
Okay. There is no such a restriction. 20, 30, 40. Even in the case of primary data, the sample size is 100 or 200. In that case also we can apply correlation. There is no limitation at all. Okay.
Thank you, sir.
Uh,
If anyone have any doubt, please unmute your mic. Then I will ask your question, please.
Usha ma'am from KSR IET. For data analysis and research in psychology, can Excel be used? Yes, Excel also can be used. Instead of SPSS, we can calculate the correlation in the SPSS also. That is okay. Degree of correlation, repeat. Already I repeated. I think it is enough.
Please unmute.
Good evening, sir.
Good evening, madam.
It was a very nice session, sir. Thanks a lot for giving a overall view of making us understand how correlation works and all that. Sir, if there
Thank
is
you.
no stars, what it signifies, sir?
Madam?
If no stars, that means there is no significance?
Yes, no star means no, not significant.
So
One
that
star
means we
means
need to reject the null hypothesis.
no. See here, I told you no. We have to accept the null hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. What is null hypothesis? There is no significant relationship between marks obtained.
Okay.
Then only we have not significant. Result is not significant. Look at this, the result. In this case, p-value is less than 0.05. So we
Yes.
rejected the null hypothesis and accepted the alternative hypothesis. What is alternative
Okay.
hypothesis? There is a significant relationship. Okay.
Okay.
If the p-value is greater than 0.05, like this, here 0.052, here 0.053, so they are not significant. That's all. Okay, madam?
Okay.
Thank you.
Sir, when we have two hypotheses, generally for a study, we'll be having two hypotheses that we are going to set. That means
Yes.
first set of null and alternate hypothesis, second set of null and alternate hypothesis.
No,
Yes.
research hypothesis.
Sorry?
Null hypothesis and
Research
alternative hypothesis. We
Yes.
frame it.
Yes.
Professor, research hypothesis.
Research
You should tell.
hypothesis is testing hypothesis. In order
I'm
to
sorry, sir.
confirm the hypothesis, we go for research hypothesis.
Yes. Super. Amazing, Professor.
Huh?
Amazing.
Thank you. Thank you.
Amazing.
Hello.
Sir, good evening, sir.
Thank you, Professor. Yes, good evening.
Sir, what about the
Hello.
two-tailed, sir? Two-tailed and one-tailed. Please explain it, sir.
Yeah. See, zero is centroid. Positive side is one side, negative side is another side. If we are comparing both, it is said to be two-tailed. Left tail is negative, right tail is positive.
Sir, whenever we are entering data, I got a set of data. If at all it is mentioned as one missing data, sir, what does it signify, sir? For example, the sample size that I have taken, that is n is equal to 25. Sir, can you hear me, sir?
See, while walking on the road, on both sides, no. Like that, we are checking and Ajit Kumar.
Sir, can you hear me, sir?
Yes, madam.
Yes, sir. Sir, I was talking about one data missing, if at all it is coming, where I have taken the sample size of 25. That is, n is equal to 25.
Okay.
And in the SPSS, then when I worked out, it says one sample missing.
If
So,
you have missed any
yes.
item, it will be shown as missing item. Or sometimes you look at here. See here, this is a common set, common
Okay.
data set. See, for some problems we have taken 20. For some problems we have taken 30. For some
Okay.
problems, we have taken 300 also. See here. Huh? Okay.
Yes, sir.
Now you look at this cell. See here, this cell.
Okay.
If you look at this cell, there is a minor dot appearing in this cell.
Okay.
Look at this, the first column,
Mm.
serial number column, up to 30 it is enabled. I mean,
Okay.
up to 400 it is enabled because we
Mm.
have taken, sorry, 500. 500 data we have taken for that another problem. So
Yeah, there
500
are dots. Yeah, yeah.
dots are appearing. No, that
Yes.
is called missing. That's all.
Oh, okay. So that means where we have not entered the value, it
In
says
that case also, see, for example, I have missed this. It will also show like a missing item. Okay.
so we don't have to consider that, no, sir. If it is okay if
You
that
just
message
check
is coming from SPSS.
whether all the columns have been filled or not.
Okay.
That is only we need to check.
Okay.
That's all. But in
Thank you,
your
sir.
analysis, your sample size will be equal, is it
Yes.
not? So this kind of missing will not be appearing. So missing
Okay.
will be appearing only when you have missed to type anything.
Okay, okay. But when there is no data to type, we cannot type, no, sir. That means one person has not responded for that question.
Yes, very
So
good
we have
question.
to leave it blank.
Yeah. See, in the case of primary data,
Okay.
this is the problem. Whether you are collecting through interview schedule or through questionnaire, that is important. In the case of questionnaire,
Hmm.
you are distributing the questionnaire to respondents,
True.
collecting the filled in questionnaires later. Is it not?
Yes. Yes, sir.
If your questions are very clear, they will
Okay.
be able to understand
Okay.
and they will give response to all the questions.
Hmm.
Sometimes, if your question is embarrassing,
Okay.
then they will not give any response. For
Okay.
example, you are asking, suppose salary, even salary or
Hmm.
income, some may not be interested in showing the salary.
True. True, sir.
Is it not? That is
Yes.
why we are not collecting the salary as a scale data. We are
Okay.
collecting it as the slabs, up to
Yes.
20 to 40,000, like that we are collecting. So they are giving response.
True, sir.
Okay.
Okay, sir. Thank you, sir.
Okay. Thank you.
So that will not impact on my the conclusion and
Yes,
the
ma'am.
suggestion what I'm going to give.
If you have failed to type anything, you have to check it down. Okay.
Okay.
Otherwise, if incomplete data
Hmm.
is collected, you have the privilege to manipulate the data to certain
Okay.
extent.
Okay.
So in that case,
manipulate
you
the
can type
data.
based on your
Yeah,
other
privilege to
answers.
manipulate the data.
Type any number.
Okay.
Thank you.
Fine, sir.
మిస్సింగ్ వాల్యూ గురించి ఆయన చెప్తున్నాడు.
Thank you, madam.
Thank
నార్మల్
you,
గా
sir.
మిస్సింగ్ వాల్యూ ఉన్నప్పుడు యావరేజ్ తీసుకుంటారు మిగతా
Thank you, sir.
Thank you. Thank you.
యావరేజ్
Thank you.
వాల్యూ
Thank you, participants. We will meet on tomorrow's session sharply at 6:55 p.m. Thank you, one and all.
క్లోజ్ చేసేసాడు. ఇంకా డౌట్లకి అప్పటికి క్లియర్ గా
Thank you, sir.
Thank you very much.
Feedback link, Professor. Hello?
Shekhar,
Sir, you will get at the last day of the session, sir. Feedback link.
Okay, 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 okay.
Thank you.
So both Zoom and YouTube we can attend.
Yes, sir. Yes, sir. I generally we plan to give the feedback link only through WhatsApp
Okay. WhatsApp link.
because
right.
every member are in WhatsApp, you know, sir.
Okay, anyway, you give it their email also, if possible.
Right, sir. Okay, sir.
Thank you, Professor. First
Okay,
day
sir.
you have started wonderful manner.
Thank you, sir.
thank you, Professor. சார் கிளிக் பண்ணிடலாமா?
Yes, sir.
Yes. Close.
Thank you.